going to wrap up our conversation about trig today and tomorrow, focusing on this idea of a unit circle trig. Okay, so on the front we start with sort of some stuff that you know, not necessarily about trig, but our first equation, our first example, talks about the equation of a circle, which that might send shivers down some of your backs. But do you remember which of these equations looks kind of like the equation of a circle from our fun work back in January? Choice 4, choice 3.
No, it's choice 3 because the choice 4 has you moving it.
Correct. Choice 4 has the center of our circle at 1, 1. Choice 3 has the center of our circle at 0, 0. If we're working with the unit circle, then we are definitely at the origin. So choice 3 is correct. This idea of x squared plus y squared equals 1 we saw last week. Do you recall we did sine squared theta plus cosine squared theta equals 1? Sine squared 45 plus cosine squared 45. Sine squared 60 plus cosine squared 60. Oops, I forgot what degrees
We did
there.
this.
I don't know, one day last week we discovered all of these, and the same thing's true for the 30s. I just can't fit them in there.
Yeah.
It doesn't matter. If you did sine squared of 17 degrees plus cosine squared of 17 degrees, it will still equal 1. If you do sine squared of 192 degrees plus the cosine squared of 192 degrees, it's still going to equal 1. Okay? It's called a trig identity. And those of you who go to Algebra 2 trig, you'll have a great time exploring those. Okay, so exercise 2 and 3 bring us back to our friends, the 45, 45, 90, and the 30, 60, 90. So, number 2, we have our right triangle over here. It's a 45, 45, 90. We're supposed to solve for x and leave our answer in simplest radical form. Now it's a right triangle, and we need to find some side lengths. What are we going to use? Pythagorean theorem. I'll do the hard part.
Yeah.
What's going to happen with the x squared plus x squared side?
2x squared.
They're going to combine to be a 2x squared. Good? Well said. Okay.
Divide by 2.
I need to get x by itself, so I'm going to divide by 2.
So this is going to be a quarter.
A quarter times a quarter does not make a half. Whatever my x is, I have to square that. So, here we go. Let's have some fun. Oh, I'll do the hard one. Square root of 1. Now, as the brilliant mathematicians that you are, do you leave the square root of 2 in the denominator ever?
Yeah.
No. No, you don't. What magic do we multiply by? Remember, we use that manipulative 1 so we can rationalize the denominator.
I guess decimal.
We will not be using decimals, just like last week. And our directions say simplest radical form. It's not just a Mrs. Inslee rule. So that's what our x values are. That should look a little familiar to you. We did that last week when we worked with 45, 45, 90s. And if you have your chart from last week, sine and cosine of 45 are square root of 2 over 2. So that should be a little familiar. We're going to do the same thing with our 30, 60, 90 right triangle down here. So, our hypotenuse length is 1, And it's very easy to find the length of the side opposite the 30-degree angle. Who remembers what to do?
Oh, is it the,
Right, it is 1/2 of that hypotenuse. So before we go any further, just get with me for a second. If this side is 20, then this side is 10. If this side is 50, then this side is 25. If this side is 4, then this side is 2. Every single time, if you know the hypotenuse, the side opposite the 30-degree angle is half of the hypotenuse. Every single time in a 30, 60, 90. One more time. Every single time in a 30, 60, 90. Thank you. Now, how can we find the height or the side opposite the 60-degree angle? You're right, Pythagorean theorem again. Fabulous. So, oh, this is a 1/2. And look at that, they even said, use the Pythagorean theorem. I love the clues that they give us. And again, Matthew, we are in simplest radical form. No decimals. So, 1/2 squared plus our missing x squared is equal to 1 squared. I will do the hard stuff. How are we going to get x by itself?
0.5?
I'm sorry, one more time,
Nothing.
but without the decimal.
Minus by 1/4.
Subtract a 1/4 from both sides. I'm going to extend my page. Oh, I lied. This should be an x squared still. Did you catch my?
Sure. Nope.
Well, glad somebody did.
No.
We do have to square root that.
One.
So, what do you got? Say it. Square root of 3/2. Beautiful. Oh boy, that goes way up there. Thanks. I'm going to get just maybe a little bit cooler with you. Way. Can I slide back up a little smidge here? Okay, thanks. So, if this is 20 and this side is 10, then this side will be 10 square roots of 3/2, or 5 square roots of 3. If this side is 50, the hypotenuse, the side opposite the 30 degrees is 25, then this side length will be 25 square roots of 3/2. If the hypotenuse is 4, and the side opposite the 30-degree angle is 2, then this side will be 2 square roots of 3/2.
So you're just automatically gonna know it's square root of 3/2?
Yep,
And you just put a number in front of it?
yep,
I like that.
yep,
Yep.
yep,
It makes it easier.
yep. To the back. Unit circle time. Those of you who go to Algebra 2 Trig next year, this will become possibly your best friend.
Oh.
Good back to you guys.
Wyatt doesn't have
Yes.
friends.
She'll review it with you. All right, let's go over some basics here. First of all, do you see 0 degrees, 90 degrees, 180 degrees, 270 degrees?
Yes.
Great. You see a circle. Good. But I guess I should have gone there first. My apologies. Let's dial it back. This is a unit circle, indicating or meaning to everybody in the world that's a math geek that this length from the radius, that's what I should say, the radius length is 1. So this location right here at 0 degrees is over 1, up 0. Just smile and nod that you're okay with that idea. All right, thanks. I'm gonna skip a whole bunch and go right here to 90. This length is also 1, because it's a radius. This point for 90 degrees is over 0. Anybody want to make a guess how far up we are?
1.
Up 1. Oh, just brilliant.
Wow.
We're gonna go to 180. We have a radius length of 1. Can someone name that point for me?
Right, over 2.
Try again.
-1, 0.
Perfect. And then, finishing off, going to 270. What do you got, Bruce?
0, -1.
0, -1. Okay. The x coordinate is considered your cosine value, and the y coordinate is considered your sine value. So I said to you, what is the sine of 0 degrees? You would tell me 0. If you put that in your calculator, if you look at your chart from last week, it will say 0. If I ask you for the cosine of 90 degrees,
0.
it'll say 0. If I ask you for the cosine of 270 degrees, 0. 0, 1.
So we just put 0 down.
Well, 0, 1, or -1, those are your choices when we're talking about the 4 corners, if you will. Correct, the main ones.
So I'll put 0 every time, then you get a 35.
Does anybody remember what 90 degree is in terms of radians, in radian measure? We did it on Thursday.
Quarter.
Lovely, but remember that we did circumference equals 2 pi r, and we know that the radius is 1.
Equals 1/2.
And so all the way around the circle is 2 pi. So 180 degrees would be how much?
1 pi.
1
Just pi or 1 pi, yeah?
half pi.
Okay, so we call that pi over 2. Want to make a guess as to what 270 is?
Pi over 3.
Power.
We're getting a lot closer. So I'm here, this is a whole pi, this is another,
So pi
Half.
plus 2.
so 3 pi over 2, or 1.5 pi, yep? Pi over 2. Okay. Those are what I believe are the 4 easiest ones to find on a unit circle. Okay? They're pretty 0s and 1s or -1s, not bad. The next ones that I think are easy are the 45-degree angles. So if 90 degrees is pi over 2, how much will 45 degrees?
It's pi over.
Pi over 4. Now, we just talked about the 45-degree angle on the front of our paper. This radius is a length of 1. What is the height and what is the length or distance across for each of those sides? We just did it on the front. Put the paper over, it's right
Square root
there.
of
Yeah?
2 squared is 2.
Square root of 2 over 2. And square root of 2 over 2. Because we just built right here a beautiful little 45, 45, 90 right triangle. How are you doing so far? That good?
No headache.
Great. Let's look at the 45-degree angle in quadrant 2.
It's the same as negative.
What's going to be negative, Matt?
The first half.
The across, the x value, the cosine is negative, but the height is positive, correct. And just because we're right here, anybody want to make a guess as to what 135 degrees is in radian measure?
Negative pi over 4.
Okay, so we're here at 0. We've got a quarter, a half, something, and then a whole.
3/4.
Alex?
3 pi over 4.
Yeah? Did you catch that? So we're here at 0. Here's 1/4, a half, 3/4, 1. Kind of a nice pattern there.
1/2, okay, 1 1/4, 1 1/2.
Let's go down and do the 45-degree angle in the third quadrant. What will this point be for 225 degrees?
Both be negative.
They're both going to be negative, and they're both still the square root of 2 over 2. I'm going to go left, and I'm going to go down. Okay, now use your math fraction brain. We went 0, a fourth, a half, 3/4, 1 full. Where are we at here at 225?
It's 5 pi over 4.
It is 5 pi over 4, because we're at 1 1/4.
Once you reach that half, you can go 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi.
Yeah, we could have gone all the way around. I'm going to go there next. Thanks. Good. And then quadrant 4, 45-degree angle.
Positive, negative.
So square root of 2 over 2 and negative square root of 2 over 2.
If you drew a line from the corners of those two triangles to hit the circle to the origin, also see what size triangle we have. 45,
I don't know what
45,
you're
90,
talking
it'd be 90.
Yeah.
You
What is
do
this
that
gonna
45,
be?
45.
In radian measure.
6.
7.
Okay, now let me make a little connection for you here before we go on to any others. And I'm going to write it over here on the side. So at 0 degrees, I'm at 0 pi over 4. Okay? At 45 degrees, I'm at 1 pi over 4. At 90 degrees, I'm at 2 pi over 4, which is really, right, 1/2, pi over 2. At 135 degrees, I am at 3 pi over 4. Anybody getting a pattern here?
You're adding another pi.
At 180 degrees, I am at
Pi.
4 pi over 4, which is,
1 pi.
right. At 225 degrees, I am at 5 pi over 4. At 270 degrees, I am at 6 pi over 4, which reduces to 3 pi over 2. And 315 degrees, 7 pi over 4. 360 degrees, 8 pi over 4, which we know is,
2 pi.
so it's 0, 1, 2, 3, 4, 5, 6, 7, 8 pi's over 4, which you then can reduce. That's a really nice pattern. Says me, the math teacher. You may not like it so much. All right, let's do the 30s and then we'll do the 60s. I'm going to erase my inner circle. Okay, so my 30-degree angle. If you need to look at the triangle in the front, go right ahead. My radius is a length of 1. Here's the 30 degrees. So what do I know is the height of this side, or the length of this side? 1/2. Because it's opposite the 30-degree angle, right? So this is a 1/2. So how long is this x side? Yep, what length does it go?
1/2 x.
Square root of 3 over 2. So this point is over square root of 3 over 2 and up 1/2. So this tells math geeks of the world, if you know cosine of 30 degrees, it's square root of 3 over 2. If you need sine of 30 degrees, it's 1/2. Because remember, cosine and sine are the x, y values. Yep.
Don't you have, for instance, 1 over 2, 2 over 2, square root of 3 over 2?
Yep.
Yeah.
Thank you. Let's come over here to the 30-degree angle. It's way out over here. Because this is the 30 degrees. So what is this point's location?
Negative 2/3, 1/2.
You're going to use these.
Yeah, negative, or 3.
So it's negative square root of 3 over 2, comma 1/2. Once you get them in quadrant 1, quadrants 2, 3, and 4 come along pretty nice. All right, and then down here, 210 is our 30-degree angle. Whoops, sorry, that's not red. So what's our location this time? Well said. And then lastly, this 30-degree angle in quadrant 4. I'm not going to ask you, I'm sorry. Now we haven't talked about the 30-degree angles in terms of radians. Are you ready? Okay. Radian measure for 30 degree is pi over 6. So if I go another 30 degrees, that's 1 pi over 6. So this one is 60 degrees would be what?
Pi over 3.
2 pi over 6 or pi over 3. So 9 degrees would be 3 pi over 6 or pi over 2. 120 is going to be how many pi's over 6?
4.
Which reduces to 2 pi over 3. So then 150 must be how many pi's over 6? Or sorry, over 3. No, I was right the first time, over 6. 5 pi over 6. And this becomes right, 6 pi over 6, or 1 pi. Am I waiting? No.
Did we just skip 135?
It's not a add 30.
Oh, okay.
Thank you. 210. How many pi's over 6? Yep. So then 60 degrees, or the 60-degree angle in this would be 8 pi over 6, which we will say is 4 pi over 3. And then 9 pi over 6. So then 300 degrees is 10 pi over 6, so 5 pi over 3. 11 pi over 6, which we leave. And then we're at 12 pi over 6, which is 2 pi. Oh, so we did the 60s when we did the 30s. Cha-ching.
So that means we should go with 60s.
We will, real quick. We can do that. I'm just erasing my inner circle. And now we're gonna tackle the 60s. Now, amazingly enough, the 60s are pretty cool. This is my, 60s were pretty cool. Come on! Oh, man. They were. So, here's my radius of 1. And look at, I have a 30-degree angle. So how long is this x value? 1/2. How long is my y value, or my height? Square root of 3/2.
So it should be just the opposite.
It is. It's exactly the opposite of what you put for 30s, including the signs. How crazy easy is that? So 60 degrees, the cosine, or the x value, is 1/2, and the sine, or y value, is square root of 3/2. And we saw those connections last week when we did the chart. We saw those flips, if you will. At 120 degrees, it's negative 1/2 and square root of 3/2. At, where am I, 240, it is negative 1/2 and negative square root of 3/2. And here at 300, it is 1/2 and negative square root of 3/2. Ladies and gentlemen, I present to you the unit circle.
This will be like a bunch of stuff that won't be able to be.
Phew! Let's use this and do number 4. There's 4 parts to number 4. Your excitement is just, yes.
I don't know how to do B in number 4.
All right. Oh, because we've gone all the way around to circle once. Okay? So if we're at negative 120 degrees, so a full circle is 360. If we go back 120 degrees, we need to know what the coordinates are for 240 degrees. And I can go right up to my little table, and my picture, 240 degrees is a minus 1/2 and a minus the square root of 3/2.
Why is this over 240?
Because we went back 120 degrees, so we were at 360, and we went back 120 degrees, so that landed us at 240.
Oh, okay.
For letter B, I'm going to subtract out 1 full circle, and how much do I have left? So I'm doing a full circle plus another 135 degrees. Okay, so that's negative square root of 2/2 and a square root of 2/2. Oh, and here's our beautiful radian measure. Remember, you can always convert, okay? You can always convert if you need to. Always.
Can't you just use it says 3 or pi over 3, so can't you just pi
You
over
can,
3?
you can, but if for some reason, you know, you're doing your homework without your notes tonight, which would be really stupid, but if you were, you could convert.
Challenge accepted.
And then 3 pi over 2, again,
70.
you can always convert.
Wait, what are we converting to? That's on the
Back to degrees,
Yeah, but that's on
so
like.
over 0, down 1.